linear equations in two variables. Cramer's rule. Condition of consistency of equation. Solution of linear equation in two variable by method of determinants. Tree diagram. Graphical method has certain limitation. We can overcome these limitations by using the determinant method of solving simultaneous equations. Let us first see what is meant by a determinant. If A, B, C and D are any four numbers, the value AD minus BC is represented as and this symbol is known as determinants. Determinants are generally denoted by capital letter A, B, C, D. This type of representation of numbers is called as determinant of order 2 as it has two rows and two columns. The value of the determinants is A into D minus B into C. In the determinants, AB is the first row, CD is the second row, and AC is the first column, BD is the second column. Let AX plus BY is equal to E and CX plus DY is equal to F are linear equations in two variable, where A, B, E and C, D, F are constant. Therefore, we write determinants of constant as determinants of X as and determinants of Y as to find the value of X, divide dx by d, and to find the value of y, divide dy by d. This method of obtaining solution of simultaneous equations by using determinants is known as Cramer's rule. Let's take one example to find the value of determinants. To find the value of A, we have to use formula to find the determinants is A into D minus B into C. Comparing the determinants with general determinants, we get the value of A is 7. Example. Solve the following simultaneous equations by the method of determinants. 2x is equal to 11 minus 3y and 2y is equal to 22 minus 5x. Now we first note that the given equation are not in the form ax plus by is equal to e. Therefore, we rearrange them. 2x is equal to 11 minus 3y can be written as 2x plus 3y is equal to 11. Say eq raised to power n into bracket 1 and 2y is equal to 22 minus 5x. Say eq raised to power n into bracket 2 can be written as 5x plus 2y is equal to 22. We find the solution of this equation by determinants formula. Determinant of constant, that is, d is equal to minus 11. Determinant of x, that is, dx is equal to minus 44. And determinant of y, that is, dy is equal to minus 11. Apply Cramer's rule. We get the value of x and y. Therefore, x is equal to 4, y is equal to 1 is the solution of given equations. Condition of consistency of equation. The equation ax plus by plus c is equal to 0, where a, b, c are real numbers and a and b are non-zero, is called a linear equation in two variables x and y. This equation may have solution x, y, which makes the two sides of the equation equal. That is, LHS is equal to RHS. Geometrically, linear equation represents a line. Every solution of linear equation represents a point on a line. Two linear equations a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. In the same two variables, x and y are called a pair of linear equations in two variables. If these two lines are lying in a plane, then following three possibilities can happen. 1. The two lines will intersect at a point and have only one solution. A pair of line is called consistent pair. 2. The two lines will not intersect. That is, they are parallel and have no solution. A pair of line is called inconsistent pair. 3. The two lines will be coincident and have many solutions. A pair of line is called dependent pair. We have seen the representation of pair of linear equations of two lines. If lines are intersecting, then a1 upon a2 is not equal to b1 upon b2. If lines are parallel, then a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2. If lines are coincident, then a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. The converse is also true for any pair of lines. The following tree diagram gives the interpretation of the solution by finding the value of the determinants. Summary. In this topic, we have learnt Cramer's rule and condition of consistency of equation. And that is all in this lesson, student. Let us learn about reducing method, application of simultaneous linear equations in two variables in our next topic. Till then, keep learning.